So forming of the equation, curved surface area is 117 pi. Find the slant height. Let slant height be L. Technically, you need to write this statement. But if you didn't, I think we all understand that pi r L is the slant height already. So actually, we are not too bothered by this statement, but good to write it. Pi r 18/2 radius times L gives us 117 pi. Pi r L. That is the curved surface area. So now there are a few things that we can do. First, I would like to divide both sides by pi. Pi is a positive number. I can divide by pi. No more. And then 18 divided by 2, that gives me 9. Which results in L equals to 117/9. 13. So L slant height is 13 meters. Any issues? If not, look at the next question. Okay, try part A. Anybody needs more time with part A? Radius? We think, can you help us with part A? -8 square. Okay, so we get how much? 6. Very good. Okay. Notice something about the numbers 6, 8, and 10. Notice anything? Huh? Anybody? Did it remind you of another 3 sets of numbers? 3, 4, 5? No? Don't it remind you of 3, 4, 5? Okay, then in the same way, we can create other right angle triangles with positive integers as the sides. Just need to multiply only. Yeah, anyway, so this is 6 cm. Next, curved surface area in terms of pi. Matthias, can you help us with part B? Pi radius. What is the radius? And last value? 10. Confirm now 8? Okay, 10. Slant height. Know the difference between slant height and perpendicular height? Curved surface area requires our slant height. So that gives us 60 pi square centimeters. They say in terms of pi. So leave it in terms of pi. Total surface area 60 pi plus the base. So pi r square. So 96 pi square centimeters. They say live in pi, so you live in terms of pi. If they didn't say, then you have to give it to 3 as that. Okay, now I'll give you some time to finish up part C first. Remember in Sec 1, when we were dealing with prisms, we talked about finding the volume of a prism. So we start off with simple ones, like a cuboid. So we say that the volume equals to base area times perpendicular height. So the base, I'm shading it, times the perpendicular height. Then we had other sorts of prisms. Maybe it's a triangular prism. Same thing, base area, perpendicular height to find the volume. And we can have very odd shapes. Same thing, base area times the perpendicular height will give us the volume. Then we went on to cylinder. Again, base area, perpendicular height gives us the volume. So this was in Sec 1. And then we learned also for volume of pyramid. We had square pyramid, volume equals to 1/3 base area times perpendicular height. So we're going to shade the base area, and this is our perpendicular height, the dotted line in the middle. That is a square pyramid. Then we moved on to rectangular pyramid. Base area, perpendicular height. Same formula. It doesn't have to be a four-sided figure. Or even if it is a trapezium base, it is still 1/3 base area times perpendicular height. If it is six-sided, it is still 1/3 base area times perpendicular height for the volume. Six-sided, 10-sided, any side. So you extend it. What happens if the base is a circle? What will the volume be? So turns out, very simple. It's just 1/3 base area times the perpendicular height. Same formula. One formula for volume for pyramid as well as cones. You can think of it this way. A cone is a special pyramid. Just like how a cylinder is a special prism. That is why our cone can take the formula for volume of pyramid. Our cylinder can take volume of cylinder can take the formula for that of a prism. So we are not learning anything extra. It is just 1/3 pi r square h. Now in the diagram on the right, label where is r and where is h. Okay, do it now. Where is r? Where is h? So R, I think you can do it. But H, does it refer to the perpendicular height or the slant height? In this case, H is our perpendicular height. Okay, complete a diagram. Since you finished. So I'll go through, I'll do practice one now for you first, just to get you to see how it's done. A cone base radius 7, height 12. When they just say height, they're referring to perpendicular height. If they say slant height, then it is the slant height. So to find the volume correct to 3SF, volume equals to 1/3 pi base area. In this case, it's a circle, so pi r square, radius given to be 7, perpendicular height 12. So 49 times 12 then you divide it by 3, you get 76 pi. They didn't say leave it in pi, so you need to evaluate. 238.76, round off, 239. I made a mistake. 1/3 base area times height. 49 times 4 times 5. What did I do? 49 times 4. My calculation error. 49 times 4, 196 pi. So 615.75. Round off to 616 cubic centimeters. If you want to draw a diagram, it looks like this. Radius 7, perpendicular height 12. So you can imagine what kind of questions they can ask from this as well. They can ask you to calculate the total surface area. And then you need to Pythagoras theorem to find the slant height. So now try practice 2 by yourself. Practice 2 now. One-third pi r squared h equals to 675. Pi r squared is actually the base area of the cone already. You do not need to find the value of r, only to put it back into the formula. So straight away, 1/3, 150 times h. This is the base area. Okay, so 50h equals to 675. H must be equal to 675 over 50. 13.5. Yeah, so I was telling some of you as I was walking around, in your volume of a cone formula, you can also make the following notes. This part, pi r squared. Highlight it. This is the area of base, which is a circle. Just unique for this case, it is a circle. Whereas for all your other pyramids, it will be whatever shape the base is going to be. Usually square, rectangle. But since you know how to calculate area of other shapes, you can also have those as questions. Okay, now next one. Okay, you need to pay attention or look at the screen. This one, highlight it. Frustum. Frustum. So actually this question introduces you to what this shape is. The top part of a cone being removed. The resulting shape is called a frustum. Must know. So find the value of this frustum, giving your answers in terms of pi. We didn't teach you how to find, we didn't give you any formula for a volume of this frustum, but you are equipped with the skills to do it already. So let's go logically. If I want to find this volume of this figure, how did I even get this figure in the first place? We start off with a complete cone, which you can find the volume. What we did after that was to remove the top piece. So you are taking away the volume, leaving behind this shape, frustum. So the volume of this frustum is simply volume of original cone minus away volume of small cone. That is our strategy. It is always the strategy for finding the volume of a frustum. Okay, original cone minus away small cone. Any questions so far? Okay, then let's find the volume of the big cone first. Volume of the big cone. Has the formula 1/3 base area, which is pi, radius 8, square perpendicular height 24. So 1/3 base area height 64 times 8. So 512 pi cubic centimeters. I want to leave it in terms of pi. Do not round off yet, because finally they said leave it in terms of pi. So this is the volume of the big cone. What about the volume of the small cone? Volume of small cone again, 1/3 base area times perpendicular height. Base area pi r square. I've got the radius, simple, 3. But perpendicular height. If this is 15, original was 24. Then this little height that was removed must be 24 minus 15. To give us 9. Yeah, 9. Okay, so volume of small cone. 1/3 pi r, radius is 3, square perpendicular height is 9. So 9 times 3, 27 pi. Then do the subtraction. Volume of frustum. 512 pi minus 27 pi. 485 pi cubic centimeters. Okay, any questions for this? If not, a variation of this is to find the total surface area. Something that you can do also. So it involves finding the curved surface area of the original cone minus the curved surface area of the removed cone. Okay, so your homework is your I think we don't need this. So this, the O-level question, and your exercise 10.2. Okay, so 5 minutes. Carry on now. See whether you can complete the notes at least within 5 minutes.